Alright, this is pretty much day 2 of me solving math problems until a Hololive VTuber notices me. So, of course we are given a polynomial here. F of x is equal to x to the power of 4 plus x cubed plus x squared plus x plus 1. And our goal is to pretty much find the complex roots with positive real parts, meaning that the value of z, where z is a plus bi, the value of a has to be positive. So, what it's asking us is to pretty much go ahead and solve the fourth degree polynomial. So you would have x to the 4 plus x cubed plus x squared plus x plus 1. And we set that equal to 0 because we are finding the roots. And here, we have a lot of ways to approach this, but I will go ahead and stick with a simple and quick method, which is simply dividing by x squared to both sides of the equation. This in turn gives us x squared plus x plus 1 plus 1 over x plus 1 over x squared is equal to 0. And what we're going to do is simply group the x squared terms and x terms, which would give us x squared plus 1 over x squared plus x plus 1 over x plus 1 is equal to 0. And here we will make a substitution and have x plus 1 over x be equal to u. So u is equal to x plus 1 over x. And if we square u, we will have u squared is equal to, and then we will have x plus 1 over x all squared. And using the perfect square formula, we will have x squared plus 2 plus 1 over x squared. So pretty much here we see that we almost have x squared plus 1 over x squared. What we simply have to do is simply subtract 2 from both sides to get x squared plus 1 over x squared. So we have u squared minus 2 is equal to x squared plus 1 over x squared. And replacing everything that we already are given, we have u squared minus 2 plus u plus 1 is equal to 0. And we could combine the positive 1 and negative 2, which will give us u squared plus u minus 1 is equal to 0. And here we could simply solve this quadratic, which if we solve using the formula, we will have u is equal to negative 1 plus or minus the square root of 1 squared minus 4 times negative 1, which is positive 4, which will give us the square root of 5, and then all over 2. And here, we can now plug in u, and we have plus or minus, so what we will do is we will end up with the following equation, which will be negative 1 plus the square root of 5 over 2 is equal to x plus 1 over x. And the second equation will be negative 1 minus root 5 over 2 is equal to x plus 1 over x. So now what we simply have to do is go ahead and solve for the two equations. And solving the other one, if we multiply by x because we have a 1 over x, we will end up with x squared plus 1 is equal to negative 1 plus root 5 over 2 x. And similarly, we will do the same thing for the negative 1 minus root 5 over 2, which will give us x squared plus 1 is equal to negative 1 minus root 5 all over 2 times x. Here we can see that we have two quadratics now, so we will go ahead and start by solving the yellow one first. So we have x squared minus -1 plus root 5 over 2 x plus 1, and we set that equal to 0. And here we will use a formula, so we will have x is equal to, and then it is, since this is negative, it's going to be positive, so we will have -1 plus root 5 over 2 plus or minus the square root of all this squared. So you'll have -1 plus root 5 over 2 squared minus 4. And it is all divided by 2. And we will go ahead and solve the orange quadratic, which will give us x squared minus -1 minus root 5 over 2 x plus 1, where using the quadratic formula we will have -1 minus root 5 over 2 plus or minus the square root of -1 minus root 5 over 2 all squared minus 4, and that is also all divided by 2. So here we don't really need to do the rest, since we know that this right here will pretty much be a complex number because this is less than 0. And similarly, the same thing can be said for the other one, so pretty much we will have complex roots. And here we can obviously tell that the real part of x for the orange one is simply -1 minus root 5 over 4, which is negative, so pretty much this cancels out 2 roots because we are only asking for complex roots with positive real parts. And finally, for the real part of x, we have -1 plus root 5 over 4. And we know that root 5 is greater than 1. So we can say that there are pretty much 2 complex roots with a real part of greater than 0. So that's pretty much the whole idea of this problem. So yeah, thank you for watching, and let's just pray that either Crony or Gura sees this. Please.